Hey, good morning, guys. Hope everybody had a nice weekend. Enjoyed their Mother's Day yesterday. Time spent with their families. Today we're going over sum and difference of day three notes. Okay, so you've been doing a nice job so far. I think you've gotten the hang of day one and day two. Please, guys, ask questions if you have any. I appreciate some feedback that I got the other day. Keep that up. Please continue. All right, so here's the note sheet that I will attach in Classroom. We're going to do the first three problems here together. We'll do them out, and then your assignment would just be to kind of, take those notes, and then on top of that, do the next six problems. Okay, and this should be enough room, but if you guys need to do it on some notebook paper, give yourself more room. Feel free to. So I just did. Let's see here. Okay, so here's the notes. It's the same problem. So you're going to be given two angles. We're told that angle A is 4/5, or I'm sorry, the sine of angle A is 4/5, and it's in quadrant 2. And we're told that the cosine of angle B is -5/13, and that's in quadrant 3. So you might have thought when seeing this that, okay, we might have to draw a triangle here, right? So we're going to draw a triangle in whatever quadrant we're told. So in this case, I'm going to draw one in quadrant 2, right? It's always kind of off zeros. That's a bad triangle, but you guys got to get the hang of it. Now, let's fix that. All right, these are supposed to be right angles here. So we're drawing a triangle in quadrant 2, and we know that we're given sine. So I'm given a y, and we're given r. So I know my radius is 5. I know the y, which is vertically, goes up and down here, is 4. And this is a special right Pythagorean triple, right? If it wasn't, I would have to do the Pythagorean theorem. X squared plus y squared equals r squared. In this case, I know that this side right here, the x, is -3, right? Because we have a 3, 4, 5 right triangle. Now, why is it -3? Because x values in quadrant 2 are negative. All right, so we have to draw that triangle, get that in front of us, get that on paper. We're going to go over here and do the same thing. We're going to draw another angle or another triangle. This time it's going to be in quadrant 3. And cosine, we know, is x over r. So the x is -5. That would be this side of the triangle right here. The radius, right, is our hypotenuse, is 13. And the radius is always positive. Right, the hypotenuse in these cases is always positive, like we've done in previous problems. This is also a Pythagorean triple. This is a 5, 12, 13. Now, because we're in quadrant 3, not only is x negative, but y is as well. Again, these were Pythagorean triples. However, if you didn't recall them or you were given a problem that was not a triple, you would have to go off to the side and you would have to figure out the missing side, right? So you would do x squared plus y squared equals r squared, okay? Now what we have to do is solve the problem that we're given. So that was kind of just like some preliminary work. Now we have to figure out what sine of angle A plus B is. So we're going to use our identity sheet. It's going to be the first one here. Remember, this is angle A, right? This is angle B. And the angle it's referring to is the angle off the origin right here, okay? So we call this one A, this one's B. It's the same thing as like 1 and 2, or it could be 2 other letters. Doesn't matter. We're calling this one angle A, this one angle B. So the identity tells me to take the sine of angle A. Okay, well, the sine of A is 4/5. And it's going to be times the cosine of B. Right, the cosine of B is -5/13. And then just following the identity, it's now plus the cosine of A plus the sine of B. the cosine of this angle would be x over r. So it would be negative 3/5. So this work here is kind of bringing up some information that we've learned from the past. You know, like if we had to go through sine, cosine, tangent, all that stuff, it's now y over r, x over r, y over x. So all that you're going to be using to solve these problems. All right, sine b, so the sine of our second angle. This one over here, sine is y over r, so negative 12/13. Take your time, make sure your signs all are correct. You didn't make any mistakes copying. All right, but we should be good here. When we multiply fractions, we multiply the numerators, we multiply the denominators. So the result of this would be negative 20/65. A negative and a negative is a positive. So 3 and 12 is 36. And then again, we have 65. So our answer would just be to simplify. We're adding fractions here. We have the same denominator. We're not worried about that. So that's 65. And negative 20 plus 36. Our answer is 16/65. You don't have to reduce. All right, even if this one you can't, but if you were to get a fraction that could in fact reduce, don't even worry about it. Just keep it as is. All right. So there's our first one. Now, for number 2, we're using the same angles, right? So we're still using angle A, angle B, the triangles that we just drew. And number 2, it asks us to solve for secant. Well, I would suggest not solving for secant, but let's use the identity for cosine. And then as we get our answer, well, it's really not going to be our answer, right? Because as we solve for this, we're solving for what cosine of A minus B would be. So we just got to make a note to ourselves that because it's secant, we're going to need to flip it at the end, right? We're going to need to take the reciprocal of whatever we get here at the end. Because if we're going to go ahead and use cosine, right, use the identity for that, well, whatever we get as the outcome, we have to make sure we take the reciprocal. Just like if it was cosecant, we would use sine, and at the very end, we would flip it to get our final answer. Okay, so we're using the identity, and it's cosine of A, cosine of B. So the cosine of A is negative 3/5. And I'll scroll back up in a second. I'll let you guys see that. But we've used these already. We've kind of already identified what sine and cosine are of each one. Cosine of B is negative 5/13. Remember, be careful with the cosine identities because as you'll notice here, right, cosine A minus B, it's now a plus. So we're going to add over here. It's going to be the sine of A, sine of B. So the sine of A was 4/5. And the sine of B was negative 12/13. Right, so we've already kind of identified these in our last problem, but like I said, we got these numbers from the triangles. We looked at cosine and sine of this one, and same thing, cosine and sine of angle B. All right, 2 negatives here. I got 15/65. Minus 48/65. And so many times, guys, myself included here, I would think that my answer is negative 33/65. So do whatever you have to do to make a note to yourself in problems like this where it asks you to do a secant or a cosecant or a cotangent. is you have to remember to flip at the end, right? Take that reciprocal. So this really isn't our answer because this would be cosine. What we were asked to do is to find secant. So your answer is 65 over negative 33. Now, I don't care where you put the negative. You can put it off to the side. You can put it in the numerator. That doesn't matter. But that's your answer. All right, for the third problem here, we're asked to do tangent. Okay, so it's still tangent of A, tangent of B. It's the problems and the triangles that we were originally given. We're using those angles. We're going to follow our difference identity here for tangent. So this bottom one right here. And it begins with whatever the tangent is of angle A minus the tangent of B. So the tangent, remember, is y over x. So you can kind of, if you need to look back up to these angles, but the y over the x. So that would be 4 over negative 3, and that would be negative 12 over negative 5. So tangent of A. All right, now it's minus tangent of B. Well, tangent of B, negative 12 over negative 5 is going to be a positive, but it's still minus whatever that outcome was. All right, so in the denominator, it's going to be 1 plus the product of, meaning I have to multiply these two together. Just make sure you're taking that sign with you. You know, as you continue to write here, just make sure you're taking the signs, you're copying the correct thing. All right, we're adding or subtracting fractions here. If we do so, we know we have to have a common denominator. So I'm going to go over here and do this. I see negative 3 and 15. So, or I'm sorry, and 5. So I know my common denominator is going to be 15. And now I think to myself, well, how did I get from 3 to 15? I multiplied by 5. So I'd have to do the same thing to the 4. We'd multiply it by 5. Now, I put the negative up in the numerator, which is certainly fine. You can think about it up here as opposed to down in the denominator. How do you get from 5 to 15? You multiply by 3, so I'd have to multiply the 12 by 3, right? Come up here if you want. So we'd have a negative 36. All right, down here, we'll take it one step at a time. You'd have 1 plus whatever the product is of over here, and it looks like it'd be 48 over a negative 15. Again, rather than having the negative in the denominator, I'm going to put it in the numerator. So it's going to be a negative 48 over 15. Again, that was multiplying there, so you just went straight across the numerator, straight across the denominator. We now have to add 1 to this fraction. Well, again, we need a common denominator. I'm going to save myself a little bit of writing here, guys. So we're going to say erase that 1, and rather than thinking of it in that way, we're going to say, all right, this is going to be 15, over 15, right? That's the same thing as 1, but now it gives us the same denominator. I'm also going to just erase this. And if we want, we could think of this now as just one big fraction. And since we have the same denominator, no reason to write 15 twice. All right, so keep simplifying here. We got negative 56 over 15. And we got negative 33 over 15. All right, the 15s are going to cancel each other out. The two negatives are also going to cancel. And your answer is 56 over 33. All right, so just kind of going back to something from the last problem, had this problem here, number 3, had it read cotangent, I would have solved for tangent. Why? Well, because we only have the identities for sine, cosine, and tangent. So I would have solved for tangent, would have got this answer, but I would have had to make a note to myself to go back and flip at the end. So if you see a cotangent, let me see here. Right, so we just did the top 3 problems as our notes. You're now going to do these 6. So you are going to see cotangents or cosecants, right? So you want to solve those for tangent or sine, and at the end, just make a note to yourself to flip, okay? And think about it, guys. Look for things like this. Like I'm, number 5 and 8 are kind of jumping out at me right now. So if I told you to solve number 8 for sine, it would be sine of A minus B. Well, you have that here. So maybe just take your answer in number 5 and take the reciprocal, and you'll have it. Okay. So guys, try to get these 6 done today. We're gonna have a quiz later this week. I believe Thursday for class 2. It'll be Wednesday for class 7. We'll have a review day tomorrow. Okay, but from what I see so far, you guys are doing really well. So just shoot me an email if you have any questions. I hope you guys try to enjoy your rainy Monday here, and I'll talk to you soon.